it's not one or the other. It is about how do you put them together and, look at from a green AI perspective rather than it's AI or green.
Hello, and welcome to Environment Variables, brought to you by the Green Software Foundation. In each episode, we discuss the latest news and events surrounding green software. On our show, you can expect candid conversations with top experts in their field who have a passion for how to reduce the greenhouse gas emissions of software. I'm your host, Chris Adams.
So hello and welcome to Environment Variables, where we bring you the latest news and updates from the world of sustainable software development. I'm your host today, Anne Currie, or your guest host. You will not be hearing the dulcet tones of Chris Adams today. You'll be listening to me. And today we're turning our attention to one of the most significant questions in global sustainability: how nations can accelerate their transition to renewable energy whilst managing the digital carbon footprint of rapid technological growth. And to help us explore this, we're joined by someone who's deeply involved in the intersection of software, sustainability, and national policy, Karthik. Karthik is a technologist, researcher, and sustainability advocate whose recent work focuses on Sustainable AI for India, a project supported by the Prime Minister's Early Career Grants, which aims to integrate environmental responsibility into the country's digital future. Drawing from his experience in green software, AI ethics, and large-scale sustainability initiatives, Karthik offers a unique perspective on how national strategies, particularly in fast-growing economies like India and fast solar transitioning economies like India, can align tech advancement with climate action. So, Karthik, welcome to Environment Variables.
Thank you, Anne. It's great to be here. Yeah, looking forward for this conversation. Yeah, so brief introduction. My name is Karthik Vaidhyanathan. I'm an assistant professor at the Software Engineering Research Center at IIIT Hyderabad, India, where I also head the Software Architecture for Sustainability Research Group. And I'm also part of the leadership team of the Smart City Living Lab at IIIT Hyderabad, India. So, of course, we have been doing some work in sustainability, especially sustainability from an AI system standpoint over the last 2 years, where we've been working with governments, we have been working with companies on how do we improve the carbon footprint of AI systems. I'm also a big follower of the Environmental Variables podcast, and also a big fan of you too, and the book that you wrote. So it's a real pleasure to be joining for this podcast and looking forward. Yeah.
Oh, thank you very much indeed, which is an excellent cue for me to introduce myself as well. So, and a quick reminder as well that everything we talk about here will be linked to in the show notes below. So my name is Anne Currie, and as Karthik just alluded to there, I am one of the co-authors of O'Reilly's book, Building Green Software, which, as I say every week, everyone who's listening to this podcast should read, because it is aimed absolutely at you, and it's a nice read. It should be really easy. It's not a heavy O'Reilly read. It's kind of steps back to the principles, and it's quite jokey. And we all, me and Sarah, my co-authors, we tried to make it as easy and pleasant to read as possible. So hopefully for Karthik's students as well. So back to Karthik. Do you want to tell us a little bit about you and what you do every day, and how you have started working on what you're working on now?
Awesome. Thanks for this question. And I mean, so the journey for this green software and AI started long back. So in fact, I was doing my master's in machine learning in 2015. So that was more about just AI. And then I did a master's in software architecture, which was in Italy. At that time also, I didn't have much idea about sustainability per se, because we were looking at more performance, reliability of the software systems and so on. But in 2017, when I was doing my PhD, in the first year of my PhD, I had a very interesting course by a Professor Patricia Lago from the VU University in Amsterdam, the Netherlands. So she did a course on software sustainability, which actually kind of shifted the way I started looking at software systems, because it also goes in line with what you have written in the book, right? Where software is also important aspect of the climate change, right? I mean, how do you consider software as an important aspect? So I started thinking about, oh, wait, I can design systems that could be mindful of the environment, or in some sense, as a technologist, I could contribute to climate change. I could contribute to improving the environment. So that kind of shifted the way I started thinking about research. So then later with my professor, Henry Muccini, for my, my PhD, we started looking at how do we dynamically adapt systems, especially IoT systems, so that they could be more energy efficient, they could be performant at the same time. So this research went on for like 3-4 years. And what happened is we also started looking at, okay, we have done it for IoT systems, can we do it for microservices, right? So we had a lot of collaborations and so on and so forth. So when I finished my PhD and my postdoc, and I wanted to come back to India, to IIIT Hyderabad, I was thinking, what can I do, right? And that's when I started thinking, okay, we have a lot of AI push that is happening. There is a lot of softwares getting built. We were looking at sustainability of software systems, non-AI systems, by using AI. So I started checking, okay, what about the sustainability of AI systems themselves, right? How do you go about that? So that's when I started venturing more into sustainability of AI systems. And because of this, over the last 3 years, we have been doing a lot of work in this space as well. Yeah, so that has been the journey so far. Yeah.
It's quite interesting. So your career in AI spans all the, I would say, 3 critical moments for green AI in the last. So the Attention is All You Need paper coming out of Google Brain in 2017. So you probably, I don't know if you even noticed it, but well, actually, I mean, OpenAI went crazy over it, but Google didn't really. They went,
Exactly.
And then you have the moment of the AI scaling laws, the realization that the more CPU cycles you threw at transformers, the better they got, with seemingly no end in sight. And then not finally, but then the launch of ChatGPT 3.5 and the incredible user demand that was, unprecedented in human history for AI in 2023. So quite a roller coaster time. How do you, because you started thinking about green before all of those things really kicked off, seemingly hurtling us in a different direction. How do you feel about that?
Oh, that's a very good question, right? I mean, when I started thinking green, as I said, AI was never the forerunner for it, right? We were just looking at green as, okay, software, because I remember reading some stats, like some companies have data centers, they are hosting non-AI softwares, and they are consuming power that could, power thousands of households in the US. So these were staggering for me to notice. And I said, at that point, since I was a researcher looking at software systems from an AI standpoint, all I was thinking about is how can I use AI for improving software systems, right? So where sustainability was one of the important concern. It was never about sustainability of AI itself, right? But as you said, when this shift happened, when people started using AI more and more, I started thinking, oh, wait, we are talking about using AI for software sustainability, but what about AI? Because that seems to be the biggest killer, right? Of course, it provides a lot of advantages, but what about the carbon footprint? What about the energy consumption, right? So that kind of started hitting very badly. And then we started saying, okay, what can we do from a research standpoint to improve it, right? So, yeah.
Yes, that must have been quite a, a period of real, probably the biggest change of direction in tech ever, fastest. I mean, because I was also around for the cloud, and I was around for the I wasn't around for internet, but I was around for Google and kind of early search and things like that, and the arrival of smartphones and the arrival of email, all that kind of stuff. But the impact of ChatGPT, that kind of like 1 million users within 5 days, 100 million users within 2 months, 700 million users today. That's unprecedented, and I think it has had an impact on green software. It has. We've spent a lot of time giving people the impression that we are saying it's AI or green, and people are therefore going, well, it's AI then. And we absolutely need to start saying it's noise, it's AI, it's green AI or not. It's not, there is a green AI.
It's not one or the other. It is about how do you put them together and, look at from a green AI perspective rather than it's AI or green. Yeah, I agree. Yeah.
Yeah. So given what you're doing at the moment, where do you think the interest currently lies? Where do you think that we are currently? What kind of, you talked a little bit about using AI to go greener, but what are you thinking are the key components of making AI itself greener?
So that's a great question. Thanks for that. Right. I mean, one of the things that we observed is it's not about models. I mean, there is a lot of focus on models themselves, right? I mean, people are focusing about what is the carbon footprint of my AI model? What is my carbon footprint when I'm training? That is all great. But when it comes to AI today, it is about AI system. It is no longer an AI model because you're already talking today about agentic systems, which is not just about model, it's an ecosystem by itself. So now the question that really comes is, how do you engineer systems where sustainability becomes a concern rather than just looking at model as one individual artifact? So I feel the biggest push that we need to do or biggest research that we still need to, kind of pursue is how do you engineer systems that are inherently green, that considers in their design principles, the greener aspect, sustainability as a concern. So for instance, when we started the research, one of the things we started observing is if you take ChatGPT, right, there is GPT-4, there is GPT-5. You don't always need GPT-5. Maybe GPT-4 can do a lot of tasks, right? Or a GPT 3.5 can do a lot of tasks. So we started understanding what if we can switch between machine learning models at runtime based on what the user writes. Instead of always using one heavy model, can you switch between different models so that you can do a trade-off between accuracy and energy? And we observed very interesting results. We observed that your accuracy can be very high, but still your energy consumption can be low because you don't need always the best model. You can go with different models, right? So that made us thinking, okay, what about, why don't we do this? Because inference seems to be apparently the most, important energy consumption factor when it comes to AI system. It is not just training, right? Training only is one aspect of it. So I think there is a lot of research that needs to be done. I'm also saying this because there was a recent event that we all attended in Lausanne in Switzerland, where a bunch of researchers, we all came together and we started looking at how do we think about greening AI from a software engineering standpoint, right? And we observed that there is a lot of challenges that we still need to solve, like lack of standards, lack of benchmarks, right? The lack of systemic view of AI, where we are looking AI as just a black box of a model. So how do we improve that? I think these are some research direction or where also industry can contribute. Yeah.
So it's interesting. You said two really interesting things there, and now I'm going to have to remember both of them to talk about them separately. So one thing which I think is I'm going to start with because it's a little bit more easy, and it reflects what last week, the week before, a couple of weeks ago, we had the head of AI sustainability from Salesforce, Chuck Morris, on the podcast, and he was saying much the same as you. Use the right tool for the job. A model is a tool. Don't use a tool that's just not, it's just not the right tool for the job. And remember that there isn't just one tool. It isn't just like, there isn't just a hammer. There are lots of other things that you can use, and using the right tool for the job is not only is it greener, it's better for the job. You do a better job for it. It's cheaper, it's faster, it's all kinds of things. So you're saying the same thing in there. Don't focus on one model. Even though we're all saying, oh, DeepSeek is really good and all that kind of stuff, doesn't mean you use DeepSeek all the time and for all the things. So just get used to AI models being a toolbox, and you pick out the one that suits you. And saying you will do a lot of work around which is the right model, which is actually similar to what Boris is doing and Salesforce, which is the right model for this job. But you also said something which I think is really quite interesting, and I don't hear people say very often, which is that using green power is about building dynamic systems that respond to their environment. And agentic systems are very dynamic. So training an AI model is essentially not that dynamic. You just go, I'm going to train it, it's trained. So there are things you can do. You can say, well, I'm only going to train it and during the day when the sun's shining, or I'm only going to train it in this location where the power's going, whatever. But you're effectively making a static upfront decision. When am I going to train it? Where am I going to train it? How am I going to train it? But as you say, agentic systems are all about your AI doing things in over an extended period. And those dynamic things, you need the system itself to decide when they're going to do the expensive things and the energy expensive things and when they're not. And sometimes that it will matter and they're just going to have to do it whether it's the energy is dirty or not. But sometimes it doesn't matter whether they delay it for 3 hours until the sun comes up. And when that's the case, you need the system to actually take that into account and make that decision and use that data. Is that what you're saying?
Yes, exactly, right? So as you said, that is one aspect. So how do you decide? So one is about choosing the model at design time. So as you said, you could choose the model at design time saying, okay, when I'm designing the system, I want to use DeepSeek or GPT or whatever. But the next part is in runtime, can I decide what model to use based on the current situation I am in, right? And this is becoming even more critical, as you rightly pointed out, in agentic systems, where today everybody are talking about building a bunch of agents. They are all using LLMs. There goes your energy over the roof, right? But instead, can you think about, agents which use small language models, which are very domain specific? And we did some research on that, and turns out that small language models can be very good in performing domain specific tasks compared to a large language model, or it's on par with a large language model, but your carbon footprint is much less. Right? So now can you decide when to use a SLM, when to use an LLM dynamically instead of putting everything static, right? So this is where we are trying to do some work on how do we dynamically decide what works better, and then can you do a trade-off between accuracy, the performance, cost, energy on multiple angles, right? Yeah.
Yeah. And of course, if you're in a country where there's dynamic energy pricing, then it just makes an enormous difference to the price, whether or not you're totally pointlessly running a large language model that just it isn't the right tool for the job, or a small language model. So you've got a couple of things there. So you've got a couple of different dimensions that you're talking about there. You're talking about which model do you use? Are you using a more expensive model than you need to do that job? And actually, of course, it will be slower as well. So it's more expensive and it's lower performance to do the job. But also you've got could you just delay the job till the sun comes up as well? Is it an urgent job or can it wait? It's very interesting because it is difficult and complex, and there's lots of things to think about, but that makes it interesting, of course.
Yeah, thank you.
Yeah. So this interests me. An element of this interests me because I'm very interested in dynamic pricing and kind of encouraging industry to actually get a benefit to burning less carbon intensive electricity, using less carbon intensive electricity. So there's incentives to delay or to be able to choose different. India is actually one of the few countries that's really ahead on this. Spain does it, India does it. I think that, and some of the Scandinavian countries do it as well.
Yeah, probably yes.
But most countries don't. And I always think that they're idiots because you're failing to get your industries actually to help you.
Yeah. In fact, touching on this, like, so if I extend further, so one of the things that industries have realized when using AI pipelines or, AI is that your AI is going to drift, right? For example, imagine that your AI is predicting A whenever you give an input as B. At some point, it might suddenly start giving C instead of, A. So the question that, then there is this principle of something called model drift that happens when the model starts drifting away from predictions. Or it could also happen your data starts changing, the input data starts changing. So what typically industries do is they have this MLOps pipeline, right? Where they frequently retrain their model, frequently update their model. And I observed very interesting things. So I was reading through some of the articles and I heard that some companies, they retrain their models every 10 minutes, every 20 minutes. The question that I was like, why, right? But why? Because they think that it improves the model's reliability. So this actually, made us thinking. So we were like, okay, maybe you don't need to do that. Can you be more mindful? Maybe you already have built a model that is already there. You don't have to just discard it. You can just reuse it instead of retrain something from scratch or retrain something on top of existing, right? And then the whole drama of what you said, right? Where should I retrain? Which instance should I use? The question that I wanted to ask is whether you should really retrain or not, right? So this is where we came up again with another dynamic approach, which is dynamically adapting your MLOps pipeline, right? Which decides whether to retrain or not. Can you switch between a model? Can you use an older model? So we started investigating, and turns out that we were able to reduce 50% the energy consumption with a similar accuracy by not mindlessly retraining, right? By just having simple sustainability practices in place. Yeah, so I feel that there is a lot of scope for these kind of works to be adopted. So we also integrated with MLflow, which is a standard tool now that is used in the industry for doing MLOps. So we believe that hopefully these kind of tools can be more adopted so that we become more conscious in terms of retraining, in terms of updating our AI models themselves. Yeah.
So that's yes. Paying attention and only retraining when you need to, rather than, as you say, just mindlessly redoing it every 10 minutes, or even, is it the right thing to do? We do only have, one of our problems with AI at the moment is that there is, and data center capacity, is that we're running up against data capacity limits. And you don't want to be wasting it. You're wasting money. So, choosing the right tool for the job, monitoring and not doing unnecessary mindless things like mindless retraining, just to be on the safe side with this AI drift. So this is interesting. I'd say you are the expert in this area, or I'm not an expert on how all these things, I'm not an AI engineer. But drift, is that something that's only happens when you use it, or is that so? Drift is obviously part of what you're saying is the data just gets out of date. But the other thing is that it actually the model just kind of deteriorates over time as it's queried.
Yes. So they say that software doesn't age like wine. Similar is the case with AI. So over time, what happens is your predictions started drifting. So that typically happens. There are multiple ways of looking at it. It could happen that the input data distribution changes, right? For example, you might be giving some similar pattern of text always to an LLM. For example, you might be always asking about, hey, I want to reduce, my saving. I want to reduce my cost. I want to reduce my expenditure. What should I do? And suddenly you started asking a different query that LLM probably was not trained for. So now what happens, right? So what happens is your data distribution has changed. So which kind of also results in the fact that the output predictions of the model might also change, right? Another example is when COVID happened, imagine that there was a company who was using AI model to predict their sales of some product. Now COVID happened, suddenly people are home and, many people had unfortunately lost their jobs and so on. So what happened is suddenly your prediction started drifting. Your curve was going in one direction. Now, because of some change that happened, what has happened is your prediction started going down. So these kind of situations, what typically you need to do is probably you need to take in the new set of data that is coming in. You need to now retrain your model and update it so that it is learning to constantly improve, right? So this is where your model can drift, your data can drift, and you can prevent it by updating your models periodically. So the rule of thumb that they say is update as frequently as possible. But what I want to say, or what we would like to say from a green AI perspective, is not update as frequently as possible, but update as and when needed, right? Where you would also really think about the carbon footprint and so on.
Actually, that kind of reminds me of in retail. I used to work many years ago. I used to work in retail, and we were always kind of like, "Oh my goodness me, we must have the data, the updated data from 2 minutes ago." It's like instant data. It's like, and sometimes that's useful, but often it isn't actually. And updating it every 2 minutes would never. It wasn't on the table 20 years ago, but it wouldn't have been a sensible thing to do, because there are times at which things change rapidly. and times in which very little happens, like overnight, very little happens. So you really need to your data isn't changing at the same frequency. But also, interestingly, in that kind of scenario, quite often it doesn't. If humans are involved, if you're doing reports, things like so, actually, maybe this is an interesting one. If humans are involved, so you're doing reports, you don't actually want the data to be changing that frequently because humans can't make a decision that can't change their minds. That we used to have a weekly sales meeting where you go, oh, we'll have more of those and fewer of those. We'll hire this model back again. We won't hire that model back. And that's was something you did once a week. On a Monday morning, you all sat in a room and went, what are we going to do this week? And so you didn't want reports every 5 minutes because you weren't acting on them every 5 minutes. You were acting on them once a week. But I guess what people are thinking now is that AI can react instantly. So you can actually have a new report every 30 seconds and take action based on it. But then you will then have a rather strange business that you're going to have difficulty understanding what's happening or why it's happening. It's an interesting one, isn't it?
You're definitely right. I mean, in today, even more so, just extending on what you said, now it's instead of humans, it's probably agents, right? These are consuming these data, and it is coming up with some insights, and it is going and saying, hey, I want to do this action because I figured out that there is potentially something going wrong. Why don't I go and do this? Right? Maybe if it is a human, you would say, oh, you know what, I have many works to do. I don't want to focus on this. Maybe every week I'll do it once, right? So instead of you have some digital entity now. It's constantly doing something which probably you don't want it to do. So this is also one other thing, right? I think that now this agentic AI is coming. Do we need agents to be always on, or can you also be conscious about it? Because it's also having a big impact on your carbon footprint that we are not yet estimating, right? We are just taking it for granted. So I think, those are some interesting questions and interesting directions to think about. Yeah.
That is really interesting. I just hadn't really thought about that at all. Because it's almost every aspect. I'm kind of like reflecting it back to retail 20 years ago, where once a week you had your meeting where you all said, oh, let's do this or let's do that. And there were people involved at every stage. So if you wanted to order more of this particular pair of trousers, you had to put a phone call in to your supplier, and then they'd say, well, we have some in stock, or you'll have to order them, whatever. And so, there was no change that you could make in, less than a second. And if you wanted to hire a model who was doing very well at converting online, and get rid of the model who wasn't, again, that was a person thing. But now you can kind of think, well, making physical things is still runs at more or less human speed, really, unless you're making 3D printed plastic widgets. It is running at human speed. But I guess models and model agencies and that kind of stuff are no longer necessarily running at human speed, because you can say, redheaded people are selling more this week, more redheaded auto-generated models, and an agentic AI can just make all of those decisions for you. And then you'll find over time, you'll be looking at a website and you'll be thinking, I wonder why I'm constantly seeing models who look a particular way. And so it's very interesting. Oh my goodness me, what a new world we are sailing towards.
Yes. There's a shift happening. Yeah.
Indeed, yeah. So yes, I mean, I completely agree. And oddly enough, I think that the irony is, the interest is that we're obviously going through a green energy revolution. It's for countries that are actually, are not living in the world of 20 years ago or 10 years ago, like the US, who are turning off all of their solar. If you're living in China or you're living in India, a modern country, then you are rolling out solar at an unbelievable rate. In 2024, China deployed new renewable generation capacity of effectively one new nuclear power station's worth of electricity every day. That was, so that's 1 gigawatt new, mostly solar, a little bit wind, a little bit nuclear capacity every single day. It's now looking at like 50 new nuclear power station every 15 hours in 2025. But as we always say, and as we say in the book, and it's like that power is not a like for like drop-in replacement for fossil fuels, because it's dynamic. It varies dynamically. You've got load, you've got hard the end. You've got load, you've got the hard the end. And so systems that dynamically respond to that are so aligned with the future that we're moving into. It's interesting. You'll know more about this than. I mean, in the UK, it's very variable. The wind is very variable. The sun is because there's a lot of, every time a cloud, I have solar, and every time a cloud goes out over, the solar power drops and up, it's back up again. India is an interesting one, and it will vary enormously country by country on how variable the power is. Presumably in India, it's incredibly variable, but more predictable than it is in Europe, for example, because it's much more, there's loads of solar in this day, and there's no solar at all at night. But am I wrong in thinking that?
No. I mean, you're right. And in fact, there are many places in India where we are already leveraging a lot of wind power. We are leveraging solar, right? So there is a lot of shift that is happening. So even in the institute, for example, even in our own institutes, we have a lot of solar panels that's installed, and we are trying to see how much energy we are able to, generate, how much energy we are actually saving, and so on and so forth. And even if you look at India as a national, from a national policy perspective, so I mean, I was just reading that by 2030, there is this goal that we want to reduce our carbon footprint by 50%, right? And by 2070, we want to make it 100%, right? So which means that there is definitely a lot of push that is also happening from the countryside in terms of how we can reduce our carbon footprint. And also a lot of initiatives are coming, right? For example, promoting EV, electric vehicles, over, the fossil-powered, vehicles. So there is also a lot of push that is happening that, next 10, 15 years can be have more EVs that is coming into the market, where people are also encouraged to buy EVs by maybe leaving off taxes. So yes, definitely there is a lot of interesting steps that are being taken from the national government perspective as well. Yeah.
Yes, it will be interesting. I've never been to India, but I remember seeing during COVID, all the photos of the reduced pollution in places like Delhi, where you could see huge distances because people are driving fewer cars. When of course that will happen again with EVs as they take over from. Which will be very cool.
So that's
yes. So, blimey, we covered a lot of stuff. I don't know if there's anything. So, what else what are you interested in talking about that you haven't talked about yet about your work or your students, or what's going on at the moment?
So one thing that I want to mention out is that, as I was mentioning about the national policy in the country, right? So where we are trying to reduce the carbon footprint. So that is when I was like last year when I wanted to write this project, I said, why don't I, create a proposal on looking at sustainability of AI systems, right? Look from a software-centric framework. So that's the whole idea of the Sustain project, that you were also mentioning in the beginning. So I was very happy because the Prime Minister's Early Career Grant, which is a grant that is established by the ANRF, which is the Anushandan National Research Foundation, which is a apex body that is responsible for funding research. They were accepting this project proposal, which also says the kind of alignment that is there probably in terms of the goals, where the country is going, and in terms of what we are trying to do. So that was very encouraging, because now what we are trying to do is we are trying to say, hey, you know what we want to achieve is to look at sustainability from 3 different dimensions. So one is, of course, environment, which is the energy, the carbon footprint, and so on. The next is about technical side, right? So how do you look at performance? How do you look at the latency of AI and so on? And the third dimension is cost, right? The money, how do you reduce the cost of AI systems, AI deployments, and so on. So we said that we want to achieve 3 things. One is we want to create a kind of a design time framework where, an architect or a developer can say, hey, this is what your energy, consumption might look like. Why don't you do this instead of this, and build systems by following some standard best practices, right? Some of this you have also laid down in your book, right? And recently we did a very interesting study, at the design time part, which is today people are using LLMs for generating code. And we observed that the energy efficiency of the code generated by LLMs, right? It's not really great. So while LLMs are generating code, they're not always energy efficient, right? So this is a recent work that we did with some folks from the FU University in Amsterdam, and that got published, right? So this is one work. And then we said, we also want to focus on runtime, which is when the systems run, dynamically, how can we ensure that their energy is reduced, their cost is managed? So this is the work I was talking to you about, right? Like sustainable MLOps, switching between machine learning models and so on and so forth. So we even did a work where we switched between edge and cloud dynamically so that we can optimize the carbon footprint and performance and so on. Finally, we also want to focus on, the cost, and the trade-off between them. For instance, how does cost impact energy and response time performance? So how do you look at the multi-dimensional aspect? So these are the three objectives we have as a project. And we also want to build some tools, create some awareness around developers, around architects, so that there could be also more adoption. So this is, something that we are trying to do as part of the project. And there for the next 2 years, so hopefully we'll be able to come up with something that could be useful for the practitioner and research community.
So that's very, so where will people find these tools, or is it an open source? Can people get involved in the project, or is it just kind of like you can conceive it and?
Oh, awesome. So the project that I was talking about, which is Sustainable MLOps, it's called HarmonE, HarMone. So we wanted to put the HarmonE word itself. So that there is a website available for that. I can, give you the link and you could link it.
Well,
so
we'll have the links in the show notes.
We'll put it there. So where people could link it. And also we have our research group website, which is public, and also the Sustain project, which is public. We also have a dedicated Discord channel in the website where people could click and join our channel, and, they could also share inputs. We will be also happy to collaborate with them. So yeah, there are multiple points of interaction where, people could join our work. So we have our research group at sa4s-serc.github.io, where people could come and check out our projects and could join our Discord channel, and they could, happily contribute to the project. Yeah.
Well, which is great, because we do get a lot of people asking about how they can get involved in these kind of things. And so this might be a really good way for you to ramp up your skills and stay on top of the cutting edge of what's happening in AI, whilst at the same time staying on the cutting edge of what's happening on green. Because as we've said, they are not two different things that can't be aligned. This is, the alignment of renewables and AI is an incredibly important thing to be involved in. And it's an incredibly important movement. And it's not only is it green, it'll save everybody heck of a lot of money.
Yeah, you're right. I think, on one side, if you look at AI, there is a lot of developments happening. It's very nice, very encouraging. A lot of possibilities are opening up, which we never could imagine before, as you also rightly mentioned in the beginning, right? So today with agentic AI, many things are getting possible. So some things that we used to take 10 hours, you could now do in 10 minutes because you have a bunch of AI that is running and doing things for you. So there is a lot of evolution that is happening, and it's unprecedented. Every day something new is happening, right, on one side. On the other side, from a green perspective, I think there is a lot of opportunity. I think, three stakeholders need to come together. One is, of course, from a government perspective, can we have more policies in place which kind of encourages, or standardizes the way you report carbon footprint, the way you report energy consumption, right? And of course, from the industry, I think that industry needs to, come up with mechanisms where they could monitor their digital carbon footprint and they could report it. And I feel this is also necessary for many countries where this is not mandated, right? So how do you have an interplay between government and industry? And definitely, I think academia has also a big role, because I feel that one of the biggest challenges today, as far as green is concerned, definitely we need to be mindful about the environment, but many people are not aware. So there is a lack of awareness that you see in the industry as well as among students. So can we inculcate sustainability in the coursework, in the curriculums, so that it becomes like a first-class citizen and not like a neglected, quality attribute where you say, hey, you know what, I want my system to be built, but I also want it to be sustainable. But instead, can we think about, I want to build a system which is sustainable, right? So can we shift the thinking into the more front, and we start thinking from the beginning that, okay, I want to build a sustainable system. So I think that's where we as a community, and also I think this is where industry, academia, and government, everybody needs to collaborate and see how we can foster innovation, research, but being also mindful of the impact on the climate and how we can improve that. Yeah.
Yeah, I couldn't agree more. Interestingly, this whole way of kind of designing systems that can flex and adapt and do more sometimes and do less sometimes, it's not new. As I mentioned as we mentioned in Building Green Software, a chapter on networking, the idea of the internet only works because the applications running on the internet are dynamic. They say, well, hang on a minute, there's a load of bandwidth now, so I'll send this giant thing, but there isn't any, so I'll hold back for a bit. And that kind of a flexibility is absolutely critical to the internet. It could not exist if it didn't support that kind of dynamic architecture and that dynamic thinking by designers of software. And solar and wind will require that same kind of dynamic thinking. And at the moment, it's a shame that it's not reflected in dynamic pricing, because if it was, it would be much easier. You'd just be able to say, well, it'll just save you money. But at the moment, a lot of governments think they're doing their citizens a favor by making life easier for them, by not pushing them to develop these skills to write dynamic software. But they are not doing them any favors, because it means that when the dynamic pricing comes along, which it has to, they won't know how to do it. So they haven't been, they haven't been taught, and they haven't learned. So it's green software is a forerunner of what everybody's going to have to do to write systems that run on renewables. That's, it's not about saving the world. It's about saving your business from being some kind of, requiring a coal-fired power station in order to run.
Exactly. Yeah. And also it's an incentive to the industry, right? I mean, ultimately, you reduce your carbon footprint, but hey, you know what? You're also reducing the cost. What about your cost? It's also getting reduced. So maybe you don't want to be mindful of the environment, but be mindful of your cost, right? So I think it also ties up nicely. Yeah.
No, totally. Absolutely. So we've covered a lot of stuff today. This has been a really interesting session. And as I say, all the links will be in the show notes. So you can go off and read all about Karthik's project, HarmonE, and get involved with it. If you're interested in AI and green, it's potentially a great thing for you, at least to have a look, see what's going on. Maybe you can make some comments, get involved, maybe have a bit of play around and try some stuff out. So it's been lovely to meet you, Karthik. Is there anything else you want to say before we disappear off?
I just want to say thanks, Anne. I mean, it was a pleasure talking to you, and a big fan of your book and also this podcast. It was great to be here and interacting with you. And I just feel that, as I said, let's make sustainability as our first-class design concern, and let's also have sustainability as an SLA, like we have availability for building software systems. So on that note, thanks again for having me.
Yeah. And thank you. So goodbye to everybody. I hope you've enjoyed this episode of Environment Variables. I will reiterate that the links will be in the show notes below. And that you should read Building Green Software, because you'll all enjoy it. And I know that not all of you have read it, because I've seen the royalty statements from O'Reilly, which are not bad, but they don't mean that every single person who's listening to this has bought it. But it was lovely to speak to you, and I will welcome you back next time. I'm a guest host on Environment Variables podcast. Goodbye.
Thank you.
Hey everyone, thanks for listening. Just a reminder to follow Environment Variables on Apple Podcasts, Spotify, or wherever you get your podcasts. And please do leave a rating and review if you like what we're doing. It helps other people discover the show. And of course, we'd love to have more listeners. To find out more about the Green Software Foundation, please visit greensoftware.foundation. That's greensoftware.foundation in any browser. Thanks again, and see you in the next episode.